A helper function is a small single-purpose function designed to perform a specific subtask for a larger, more complex function. This is a principle called separation of concerns. Instead of writing one massive 100-line function that handles a bunch of different calculations, data filtering, console formatting, etc., you break those duties into bite-sized helper blocks. Not only does this allow for you to have code that is reusable, it turns your code into a form of documentation. Reading through the primary function should feel like reading an instruction manual, where all of the details of how one particular part works are hidden inside the helper function instead. So in short, every function should have one job. All of the small functions will encapsulate the code that is specific to their purpose, and the function will be named in a way that we know exactly what it does. The primary function will make use of those functions, but not become so complicated that it is hard to understand what is happening overall. Let's work on a short example where we'll build two helper functions and then use them within a primary function to keep everything clean and easy to read. So I'll define my function with the function keyword, give it a name that tells you exactly what it does, Celsius to Kelvin, and we'll define a parameter Celsius and then return Celsius plus 273.15. And that will convert it to Kelvin. So that function is very simple. It has exactly one job. It's reusable. And the name of the function tells us exactly what it does. Let's do a second one. This time we're going to have something that's very specific to our program. Is overheating. So this is going to be a Boolean check where we'll give it the Kelvin temperature and then define a constant, critical temp, K for Kelvin, is 3000. And then we'll return the Boolean expression, Kelvin temp is greater than critical temp K. So just to be clear, this entire expression is a Boolean expression that will evaluate to true or false. So we're asking the question, is it overheating? And if this is true, if the temperature is greater than 3000 Kelvin, it will return true, otherwise it returns false. So we have two good helper functions that will allow us to write a nice clean primary function, which we will call run reactor check. We'll accept the temperature in Celsius, and then work through a sequence of evaluations that ultimately will help us decide if there is a dangerous problem with our reactor or not. So first, let's go get the temperature in Kelvin. We'll call our helper function Celsius to Kelvin and give it the current Celsius that was passed into this function. So this is our local variable that we can use that represents whatever's passed in when this greater function is called. We pass it into Celsius to Kelvin, and it receives it under the name Celsius. And then we can use it to help return that value and store it in our variable temp and Kelvin, because this entire expression is the return value from this function. So now we have our temperature in Kelvin, and you can probably guess where we're going. We're going to check and see if we're overheating or not. So we'll call it threat detected, and we'll check is overheating and pass in the temperature in Kelvin. So we pass that in, it gets accepted here now that is overheating has been called, and we check it and it returns true or false. That value is now stored in threat detected. Now we can have some simple logic to decide which report to make. If threat detected, we'll log critical. Core is at temp and Kelvin, and then K for Kelvin, initiate containment. Otherwise, so we'll say else, if a threat is not detected, we will log core nominal, operating temperature, and insert temp in Kelvin, K for Kelvin. Okay, so now we have three functions, our two helper functions, and the primary function that runs the entire sequence and ultimately prints a report depending on whether a threat was detected or not. I can run this file right now and nothing happens. And you're probably thinking, but we just wrote all of that code. Why aren't we seeing anything? That's because we haven't called it. So the thing about using this entire pattern of putting everything inside functions is that ultimately, if JavaScript is just running this file from top to bottom and all it sees are function definitions, but it doesn't actually see any executable code in scope, you need to add a call to that primary function so that it has something to execute. So let's call run reactor check, and we'll just feed in a value like 2800 and run it again. And now we see critical. Core is at 3073.15 Kelvin. Initiate containment. If we were to run this again with a different value, say 1200, we see core nominal operating temperature 1473.15 Kelvin. So that's all there is to it, and this is how code is written professionally. We encapsulate code inside of functions, and we only execute the functions that we need when we need them. We try to isolate small, specific blocks of code in small helper functions and leave a primary function to just control an entire sequence when we're ready to run our program. Let me make a quick commit. And we'll look at your practice. You have an opportunity here to do a couple of different exercises where you can create a helper function and then insert it where it's needed in your primary function. And you'll notice that I've set these values to null here. That's just a temporary placeholder until you're ready to write your code. That's all I've got. I will see you in the next one.